All right. All right, good morning. I thought I would do an earlier stream today. I'm still experimenting with my new schedule. I think this time is better, but I'm not 100% sure. So we'll see. So, hello, FLGA. How you doing? I'm just gonna get something up on the screen here. Let's see. Do I have anything I need to commit? Yes. Quite a bit. Okay. Just a second, I'll just stash this. Alright, so this is kind of where I want to get back to. Except without this annoying printing. Let's just get rid of that. What did I call the stream? Render compositing, right. Yeah, so basically I'm referring to... Hang on, I gotta turn this music off. It's weird, I can't talk and listen to music. It's not even... It's instrumental music. It doesn't even have words. Anyway, so this scene is composed of three render passes. But the first render pass is this model, which has some direct lighting, not direct lighting, directional lighting coming from the sky. Actually, I don't remember which direction it's coming from. And then we've got the second scene, which are these debug shapes. Oh, and the first render pass also has this light as well. This light is part of the first pass. Second render pass has these debug shapes. And then the third render pass is combining them together and rendering them to the screen. So I was doing this in SDL3. And if I close this, you can see the code is pretty long. So I got a default pipeline that starts here. So I got one pipeline. I'll just scroll down a bit. Now I got a second pipeline, the debug pipeline here. And then a third pipeline, the composite pipeline, which is here. Which is pretty... It's a lot. Now, if I check out the Vulkan branch, and I'll apply the stash. Let's see. Yeah. So I was asking the Claude LLM about how to do dynamic rendering. It was pretty good actually. But basically, well, it's a bit different. But essentially, I have one render pass. I don't even have a render pass. I have one pipeline, which is where is it? Actually, I'm not going to show you the pipeline setup. It's tons. But then you can do something really cool, which I didn't know about in Vulkan, which is I start rendering. Where is it? The first time here. Start rendering using the graphics pipeline. And then I set up some stuff like the viewport, cull mode, front face. That's all dynamic from the tutorial that I was following. And then bind the vertex buffer, draw, end rendering. And then I can just modify the vertices, update the vertex buffer, begin rendering again, draw, and then end rendering again. And then finally present it to the screen. So actually, a lot of the stuff that I was doing in those huge blocks of code, I can just do directly, like right here. So I think in something that seems a little bit ironic to me, that the Vulkan is going to be less, not less code overall, but I think it'll be a bit simpler to implement, because you don't have to implement a full render pass just to do another draw call. Maybe you could do the same thing in SDL3 and I just didn't know how to do it, but yeah, it's pretty cool. And this produces, actually I should probably show you what this produces. It's nothing crazy, it's just the triangle and then the triangle shifted to the right. So, yeah. It's just remembering. Dynamic, not a graphics programmer, you just dabble, and dynamic rendering is a huge quality of life change for sure. Yeah, I didn't really look into it. So I've tried Vulkan a few times before, and I didn't get up to a point, like I got up to a point of rendering a triangle, and then I didn't really understand, I guess, everything well enough to understand the benefits of dynamic rendering. But now that I know like what a pipeline is mostly and what a render pass is and sort of how they work, how to set them up and stuff, well, yeah, this is really cool. And you can even, if I remember correctly, you can, there are some commands for changing the shaders. So you'd have to set up another pipeline, but that's fine. So you can even bind a new pipeline down here. And I think you can draw to the same, you can, sorry, bind a pipeline down here and then draw. Yeah, I don't know, I have to figure it out. I'm a bit tired. Okay, 8 AM stream. Maybe a little bit too early. It's a good time though for the Americans, and lots of my audience is American. Oh well, that's fine. Okay. So, what I want to go through today is basically getting this project to draw what you could see in the other project, which is, well, it's the same project, but getting up to that point. So, I've still got the model loading, right? So that's, I think it's here somewhere. No, where is it? GLTF. The model loading should just work. I don't have to change anything. And that will get me something rendering on the screen. I also need to have a uniform buffer for this shader. So let's have a look at the shaders that we're using. I think I'm using shaders from the tutorial, so I want to change that. Search for SPV. So I'm using Hello Triangle. I probably want to change this to Simple 3D. And if we have a look at the Simple 3D shaders, let's see what we got. So we've got a position and a color, which are vec3s. I believe this color is actually normal. I use them as normals. So I should probably just rename that to normal. And then where did I use it? Oh, here. So frag color, I'll call this out normal. Frag position, I'm going to call out position. Why do we use that? I can't remember. Yeah, okay. I used to think that the names had to match when I first started shader programming. I'm pretty sure they don't have to match. It's just the location and the type. So I'd always have problems naming, like from the Vertex shader that you have to pass to the fragment shader. I would be like, oh, I don't want to call this out, because then when I'm getting it from here, it's called out, and that's confusing. That's actually backwards. There's the normal and then the, hang on a second. Oh yeah, normal position. Okay. Alright, that's fine. I'm just going to leave those names. So we got a uniform buffer object which is bound to set1. The reason I did this is because STL3 has preset uniform buffer object, uniform buffer bindings. So you have to use the correct set. So it's set1 for vertex buffers and set3 for fragment shader uniform buffers. So let's have a look. I haven't really messed around with uniform buffers in Vulkan yet, so I'm gonna have to do that first. So let's see, the pipeline creation is probably gonna fail now, right? Yeah, because why is that? So we've got for each set n that is statically used by a bound shader, a descriptor set must have been bound to n at the time the pipeline bind point, etc., etc. Right. Yeah. Okay. So here's the default pipeline. We're already in there. I need to set up a uniform buffer, which is, I don't know, binding description, I guess. Some kind of binding description. What is this? Attribute descriptions. It's not in the vertex input. That makes sense. Where would it be? The layout info? What's a descriptor set layout? Sounds like it might be what we want. Okay, it's a handle that I can't view. Maybe not. So this is not what I want, I think. Unless I've got to create one somehow. Let's have a look. I've got to look at the docs for this. Actually, I could just look at that error message. I think it probably tells me. Let's see. So the pipeline must be created with this pipeline, uses descriptor set 3, which is not compatible with the currently bound descriptor sets pipeline of 0. Okay. So, pipeline layout that is compatible for set n, the pipeline layout used to create the current pipeline. Yeah. It's got to be in the pipeline layout, right? So a VK descriptor set layout is a descriptor set layout object. Okay, which means I guess we have to make it. This is not a very useful page. Let's see. I will refer to LSP browse programming. So I'm going to browse the functions. So descriptor set layout binding flags create info. So descriptor set layout create info. I probably want this, right? I shouldn't have named it. I'm probably going to have to change the name. Okay, cool. So we got the bindings, descriptor set layout binding. Okay, so I need a descriptor set layout binding, which is a struct. Good. Okay, it's got a binding which is just a number. Okay, we'll just set that to 0, although we don't have to set it to 0 because it would already be 0. Descriptor type. Yeah, this is what we wanted. So we want a uniform buffer, I think. What's the difference between uniform buffer and uniform buffer dynamic? I think we want dynamic. I should look that up, because we're going to be updating it every frame. Dynamic uniform buffers are used for rendering multiple objects with separate matrices. Oh. No, but I will use that later for a different one. So we just want uniform buffer. Okay, and we want descriptor count. Stage flags. So this is going to be vertex, right? What's the descriptor count? I don't know what that is. Let's see. I'm trying to do everything I can not to open this website. No, this one's okay, I think. Is it this one's okay? Yeah, this one's okay. If you get to the Vulkan specification website, I think I've talked about this every time. It just freezes my browser. Because it's... they just put everything on one giant page and it just can't handle it, I guess. Okay, so I want to know what this is. The resource descriptors. Oh yeah, that's what we just did, not that one. Stage flags, so we're going to use vertex, and then... Oh, that's cool. You can use shader stage all, and you can just access the same uniform. That might be useful for something. Immutable samplers. Well, we're not doing samplers right now. Okay, corresponds to the same binding number in the shader stages. That's fine. The number of descriptors contained in the binding. Okay, so you could have... Wait, what? The number of descriptors... I see. Accessed in a shader as an array, except if inline uniform. The binding entry is reserved at the resource, and the resource must not be accessed from any stage via this binding within any pipeline using the set layout. If the descriptor count is set to 0, the binding entry is reserved. So we need to set it to something. So I guess I will use... Okay, I will try 1, and then we'll see. I will explicitly state binding 0. This is going to be the UBO binding. Okay, so this is going to be linked to... Oh yeah, we've got to give it a type. Does this have an S type as well? No, because it's not a create info. Okay. Descriptor layout create info. Okay, we'll just set this one to UBO binding. Flags. Okay. Push descriptor. What is that? Not sure. I'll have to look that up. Binding count is 1. I'll leave flags empty for now. Apparently that's not valid. Why? Oh. Descriptor set. Okay. So this should give us a set layout count of 1. And then layout sets is going to be, wait. Yeah. No, I didn't create it yet. I need to create it. So probably something like vk.create descriptor set layout. There we go. At least the naming conventions are really, what's the word? Uniform, predictable. Descriptor set layout create info, good. No allocator callback, and the p set layout, descriptor set layout. That's where I'm going to put it. Okay. Whoops. Okay, so we should have enough to put in here. Set layout count is 1. I think I probably want to use push constant, don't I? I'm going to look at that in a second. Instead of this uniform buffer thing. Because it's just 4 matrices, or 3 matrices. Let's have a look. Set layouts is descriptor set layout. There we go. Okay. What's the error that we got this time? The fragment shader uses descriptor set 3. Yeah, right, okay. That's fair. Alright, let's have a look at the fragment shader for a second. Maybe I should just change this. I don't need to return, I need to do out color is okay, we'll just change it to this for now. Need to recompile the shaders. And then recompile again. Alright, there we go. Okay, that did not work. Oh, did we use set 1? I thought I turned that off. Right. I'll just get rid of this. Binding 0, yeah. That should be fine, I think. So I need to build shaders again, and then build... It's really annoying. I unified the build steps previously, so it built the shaders every time and then built the program, because the way I'm loading the shader code is using the compiler command here to load the bytes directly in. But that means that this has to be compiled, which means I got to compile the shaders, but then I added tons of shaders, and then it took like 2 seconds to compile the shaders every time, and that was annoying. So I need a better solution. Probably just load it dynamically at runtime instead of at compile time. So we're using descriptor set 0, which is not compatible with this pipeline layout, which is apparently out of bounds. Okay. So we did not succeed. Why? Okay. So layout info is here, but binding count is 1, descriptor count is 1. And we're using this right here for our layout, and then we're creating the pipeline layout. That's, yep. And then we use the layout in the pipeline creation. And what am I missing here? Hey Anton, how are you? I'm good. Binding, stride, vertex. Okay. I'm a little bit sleepy. I don't know if early morning stream is the best. I'm drinking a coffee, so I'm sure I'll be alive soon. Oh. We're gonna finish the Metroidvania, I think this week, maybe next week. I don't like giving predictions, but it's really close. Right now, working on porting my engine as much as it is, not really an engine yet, more like a renderer from STL3 using the GPU API to Vulkan. So specifically right now, I am just trying to add a uniform buffer to the pipeline. So we got here a binding uniform buffer on the Vertex shader. Descriptor count, I don't know if this is correct, but set layout count is 1. Set layouts is here. Thought this would work, but yeah, no. I guess I could click this link. It's gonna crash my browser. Well, it'll make my browser freeze for a while. It'll probably give me no good information. Sometimes it does. Sometimes it basically just says the same thing, but at the link. So for each set n that is statically used by a bound shader, a descriptor set must have been bound at the Okay, so I got to do something like bind descriptor. Is that a thing? Bind descriptor set info. Wait, what? What is this? Okay, so we fill out this struct here. Then we call bind, is it? Or is it cmd bind descriptor set? Well, what's the difference between 1 and 2? Command buffer, bind descriptor sets info. I think we want this one. Because we're using Vulkan 1.3, so we should probably use number 2, but I don't know what the difference is. Let's see, is there a pipeline bind point layout? Okay, this is probably not what we want. We probably want this one. Okay, so down here where we're drawing stuff somewhere, so we bind the vertex buffer. Then I guess we also need to bind the uniform buffer. So I gotta set a pointer to this, which I'm gonna call bind, what should I call it? UBO descriptor or something. Ah, God, who knows? I'm just gonna call it descriptor, which is not the right word, but that's fine for now. So layout, it's gonna be Wait, actually, we're not going to pass that in, I think. We're going to use another function probably to create one. Create. No? Okay, we're not. Okay. So stage flag is going to be vertex. Yeah, that makes sense. The layout is going to be the pipeline layout that we have here on our context pipeline layout. First set is going to be 0. Descriptor set count is going to be 1. Descriptor sets, hang on a second. Oh, I'm glad to hear that, actually. And awesome that you're doing a game jam next week. I think that's a really good way to learn. I did a bunch of game jams. I really want to do them again at some point. So descriptor set, see, this is a problem. We don't have a descriptor set. Well, we do, but they're in our initialization up here. I think. Yeah. No, this is a descriptor set layout. So we need to make a descriptor set as well. Okay, let's have a look at that. Create info, descriptor set layout. No, there's only... Alright, how do you get one of these descriptor sets? So it's just called vk.descriptorSet. Okay, we need to create one from a function, because that's how you get those handles. Let's have a look. They're allocated from descriptor pools. I got a feeling I'm doing this a bad way. Maybe I should just use push constants. Small amount of data to the shader in a very simple and performant way. They can send it any stage. We're going to need a new pipeline layout to hold the push constant size. If you've never done a game jam before, I would highly recommend... Are you going to do it by yourself or with a team? That's probably the first question. And how long is it as well? Mesh push constants. Okay, so we got this constant thing that we're going to push. That's fine. Mesh pipeline layout. Info. Okay. Right, so this must be what they were already working on. Then they create a push constant range. Have a friend of yours, you've done a bunch of small game prototypes together. Oh, nice. So you already got working synergy. That's good. Then you probably already know how to work with your friend. Game Jam is the Bracky's Game Jam. Oh, cool. Oh, you're taking a week off work for it? Nice. That's pretty cool. Yeah. That sounds good. I don't think I have anything really to tell you because you already know how to work with someone. But I'll just say what really tripped me up in the past was changing the idea like some way through the jam. So what we ended up doing, I used to work with another guy. He was an artist and we would do game jams. And then we got into the situation where we would like, make one version of the game in the first day, and let's say it was a 3-day jam, and then the next day we actually just scrapped the whole thing and made another one, and then the next day we scrapped the whole thing and made another one, and then it wasn't very good. And we kind of did that a few times, or like scrapped it at the last minute. And then eventually we decided to just have a small amount of time, like let's say it was a 1-week thing. You take the first day to do tons of really, really quick little things, little prototypes, depending on, you know, how fast you can do them and stuff. And then just work on that and just stick to it. Because throwing it away just kind of, I mean, you lose all the time for polishing and all that kind of stuff. We can already vote for the theme, so I know what the themes can be. So we can try not to spoil too much planning. Okay, that's cool. Okay, so I think what I'm just going to do is use push constants. Because that just makes it much easier, right? And then in the shader, where do they say? The shader is just uniform push constants, yeah. What does this mean? I don't think that's... Has to match the struct? Yeah, that's not valid, is it? Maybe it is. Why do they write it with the spaces? Probably reading too much into it. Okay. Alright, let's try this. So we need a push constant range, which is really easy on the vertex. That's fine. And then we just put it into the pipeline layout info. So instead of all that uniform stuff we just did, alright, get out of here. Instead of setting up these bindings, I'll just delete this. We're going to do push constant range. There we go. It is valid. It's valid GLSL. Interesting. So the size is going to be size of... I think I've got the variable here called MVP somewhere. So that should be fine. Oh no, it's not declared yet. Okay, it's going to be size of, yeah, GLSL mat 4 times 3. Have I worked with Vulkan? I've tried working with Vulkan 3 times before. And every time I didn't know enough about graphics pipelines to really get very far, and I ended up not using it, or thinking that it was too much work. Like the gap was too big. Actually, I kind of spoke about this yesterday, but this was kind of my experience. So Raylib, or you know, other really simple graphics libraries that you can use, like processing or HTML5 canvas, a lot of things that you can just draw things with, Pixie.js, and then progressing to like OpenGL DirectX 11, and then it's like, okay, the next thing's Vulkan, but there's this huge gap here. And then I thought, after I used this SDL GPU API, I used it for a few days, and after using that for just a few days, I felt like, okay, I can actually make the gap now over to here. So that's what I'm trying to do. FLGA says you may want to look at buffer device address. Essentially, you can just send a buffer pointer instead of going through the descriptors. Like you said, you're just a novice, so you can't speak authoritatively beyond it's a neat feature. Okay, well, that sounds good. Hey, I've got no idea. I'm new to Vulkan, so let's have a look. Okay, it's a very powerful and unique feature to Vulkan. Oh, okay. Which is not present in any other modern graphics API. That's cool, you've never tried SDL and you just knew about SDL2. SDL3 just came out a few weeks ago. And what it has with it is a new API called the GPU API. I'll show it to you here. So the GPU API is actually, I mean, I called it something like Vulkan Lite. Some people may take offense to that. However, that's what it feels like to program, because you've still got to do stuff like create a graphics pipeline, create a render pass, and bind the graphics pipeline and do all that kind of stuff. But it's much simpler. It's got a lot of stuff is done kind of for you, but it still kind of gives you the idea. And this page specifically was really good. So I like the way this is set out. It just says a basic workflow might be something like you create a device and then you claim the window for this device, and then you set up your shaders with this function, and then you upload some data with this function, then you upload some images with this function, then you create your texture sampler with this, and then you create your pipeline with this. And all you have to do is click each thing, like, okay, I've set up this one, now I'm going to do this one. Okay, now what do I need to do for this? And then it's got some information here and stuff, and you just kind of walk through it, and at the end you've got a full modern graphics pipeline setup, which is pretty cool. It's got some limitations, just because the way they programmed it, it's got some set configuration which you have to adhere to. So I would look at create GPU shader, this one, and then make sure you read this part. So if you use this, because otherwise you're not going to know, oh, my uniform buffers don't work, so why not? And then Vulkan's going to give you an error, and maybe you're not good at reading Vulkan errors because they look like this, and it can take a while to get used to reading something like this, right? Especially like for each set n that is statically used by a bound shader, a descriptor set must have been bound to n at the same pipeline bind point. Like, if you don't know what this is talking about, this is just going to seem like nonsense to you, right? So, yeah, I just thought that was really cool. So it really helped bridge the gap there. And so I'm going to keep shilling for them. We were looking at something, this buffer device address. You know what I really don't like? I don't like that the official documentation uses this library, this abstraction library called Vulkan Bootstrap, because it just assumes that you're going to use that. It's like, imagine you're writing a well, I don't know if I can even think of something else off the top of my head. Let's say you're writing a web server and you're writing it in C# for some reason. C#? Maybe not C#. Maybe, let's just say C++. You're writing a C++ web server. And then all your code has like boost stuff. Like, you're always using boost in your example code. So now the person who's using your library is kind of forced into using boost or trying to figure out like, what the hell does this do? You know? Yeah, anyway, I just don't like that. They do it in the GitHub examples as well. They use Vulk, which is a loader, and they use Vulkan Bootstrap, which is it's like a way to shorthand a bunch of the stuff. FLGA says, agree, I had to go check the source a couple times to figure out what and how it was initializing things. Yeah, just makes it harder. for you, unless you want to buy into the whole ecosystem. Like, oh yeah, I'm going to use C++, I'm going to use Vulkan Bootstrap, I'm going to use Volk, or I'm going to write my own bindings for these things if I want to use a different language. It's just, I just don't like that. But anyway, that's enough ranting. Okay, so we're creating a buffer. As you told me at work, we use Java, and you're helping out. You're going to help out some smaller bugs in the trading/clearing systems, and you use Spring, so you gave up. Yeah, I don't know much about Spring. It's a Java thing, right? I think I've heard of it. Level up your Java code. What is it? A learning platform as well? Oh yeah, this thing. Wait. Oh, okay. Yeah, this is like, I used to think this stuff was cool when I was a junior web developer. I was like, wow, look at how much we can do with just like 3 lines of code if we use this library. And then it's like, oh yeah, but now you can't customize anything. You have no idea what's going on under the hood. You're beholden to all the decisions that the people that made this library make. So if they change something that screws up your entire system, you can't modify it, and blah blah blah, all that kind of stuff. Pablo, how are you doing? Pablo says it's a glorified dependency injection framework. Gotcha. I think, is that what you mean by DI? You work in Java as well, says Pablo. Really trying to move to Kotlin. It runs in the VM and is much nicer language. I really recommend it. You should see some of the SQL queries because you use annotations. Talking about Spring, 100 layers of abstraction. I've heard good things about Kotlin as well. Yeah, a lot of people say it's nice. You've seen some joins having 300 plus joins in a query because people don't understand the annotations. That's great. Okay, okay, I need to get a glass of water. My eyes are like sandpaper. I'm gonna make 1 coffee, but I'm gonna mute the mic. 1 second. I'll be right back. All right. Okay, I'm feeling much better. I woke up and I forgot to drink water. And then I just drank coffee. Okay. Okay, this looks really cool. I'm gonna not use it right now. I think I'm gonna go with the push constants. Thank you for welcoming me back. I appreciate that. Looks like you guys are having a nice chat in there. So I'm not gonna read out all your messages to each other. That would be strange, I think. Offset to 0. Okay, so MVP is, I've just called it a struct MVP. Okay, that's fine. We could do that. Push constant range is what I was looking at. If just sending a small amount of data, then push constants is definitely the easiest. Okay, well that's good. Just sending 3 4x4 matrices, so it should be fine, I believe. They have a minimum size of 128 bytes, which is enough for common things like a 4x4 matrix, and a few extra parameters. Okay. What's the maximum size though? Oh. 128 bytes. This says minimum size. Not to backseat, but yeah, 128 bytes is usually best spent with your view, projection, and normal matrices. Yeah, how big is a 4x4 matrix? I actually don't know. So it's what, 4 bytes times 4x4, 16 times 4 is 64. So we could only fit 2, right? Model and normal matrices. Model and normal. Model and normal. What is normal? Is normal view times projection? Or normal referring to the model orientation or something? Some devices do more, and you can optimize them for something like 60% of Android devices have only 128. Yeah, I'll probably just assume 128. So maybe I want to do the matrix multiplication on the client side and just send the MVP. I mean, that would make sense, right? And then in the shader, normal matrix is the matrix you'll use to transform normals on your model. Oh. I always send my normals as, I just send them in the Vertex buffer. I never thought about transforming them though. I suppose they would need to be transformed, hey? If you rotate the model, the normals need to be rotated, don't they? Yeah, I didn't think about that. So I need to look at, not this one. Not this one. How did I do that twice? Simple, 3D, but there we go. Oh yeah, but they're not in world space. So actually, do I need this? Fragment shader. I do. I need this model matrix. So I can send two, I guess. So I'll send view projection together and model separately, like that. I think that will be fine. That will fit, right? Sorry, first time watching the stream. Big fan of my content. Well, thank you. Helped you take first steps in game dev. Well, I'm happy to hear that. That's awesome. I don't know why you're saying sorry. You're telling me useful things. That's great. So I'm going to say this is going to be ×2. Actually, you know what? Yeah. So we'll send the two matrices. That's fine. I think. Now we've got to set this up somewhere. Probably here. Push constant range count is 1. Push constant range is going to be this thing that we just made. Okay, and then in the shader, I guess this is going to be push constant. I'll just rename it. View projection is good for a uniform because you only need to send one per frame. Model and normal matrices are per object, so it's good to have them in the push constants. Oh, okay. Hang on a second. So push constant is not supposed to be updated every frame? I guess that's why it's called constant, right? So you send it once. So this is not what I want. Let's see. Well, you can. I think you probably can still push them every frame. Is that Brian? Hello, Brian. How you doing? It's just hard to read the Twitch chat color. It's like this bright blue on the gray background of my OBS. But yeah, that's good. You can write to push constants anytime you want. You use it in your per object rendering loop. Constant in the sense that it's recorded in the command buffer. You can push per frame. Oh, gotcha. Is that better? Yes, that is better. Thanks. How did you change your color to green? That's cool. You don't know, you just saw a color picker. Okay, nice. Okay, well, we'll try the push constants first. I gotta do it down here somewhere. So I suppose after we bind the pipeline, before we draw, I'll just put it here. CMD push constants. What's the difference between push constants and push constants 2? That looks good. That looks less good, maybe. Standardized kidnapping. Wow, what a name. I didn't know the bot problem was so bad on Twitch, huh? I gotta go to the Twitch chat, one sec. How do I get rid of this person? My microphone stand is like in the way. There we go, get out of here. Isn't even worth blocking them? The accounts are temporary? Yeah. I suppose so. I need a bot to do it. Yeah, that's funny. I have the stream elements bot in here. What is it good for anyway? What's render compositing? Basically, I am trying to compose two draw passes onto each other. I suppose that's the best way to put it. So I had this set up already with STL3, but now I'm using Vulkan. What does that enable me to do? Basically, I can do a render pass on the scene and do all the lighting and stuff on the models and shadows when I get to that. And then I can do another render pass for debug. And so I can have like floating wireframe spheres and cubes and things. I'm mostly using it for debug right now. And then probably for text as well, I'll do another composite on top. So that's interesting. I guess I want this one. Layout, stage flags, vertex, offset 0, size, size of, I'm gonna have to change this. I'll put it in a struct later. And the value is gonna be, I guess I'll just make it right here. So I'm gonna make the glsl.mat4. Gonna make 2 of them. First one is gonna be projection times view, and the second one is going to be model. I think that's right. Yeah. Okay. Of course, my vertices are all totally wrong right now. But let's have a look. See if there's any errors. There are errors. Is all of this render code in a big render system? No, right now this is just in a normal game loop. There's nothing crazy going on yet. Okay, so what did we get here? The pipeline created with this uses a descriptor set 0, which is not compatible with the currently bound descriptor set's pipeline layout. Not abstracting any of the Vulkan stuff yet? No, I only started Vulkan yesterday. So not yet. I'm not gonna make an abstraction too early, because I know I'll mess it up. I don't understand how to abstract it yet. Maybe in a few months. The descriptor set must have been bound. That's weird. Let's see. I got disconnected? Or did I get disconnected? No, I'm not abstracting any of the Vulkan stuff yet. What if I just don't do that? Oh no, it's the shaders that have the problem, right? Yeah. Okay. So right now, if I change the other shaders, where are they? Pablo says, great call. Trying to do abstractions for Vulkan is hard. Yeah, well, I learned my lesson because I made an abstraction for SDL3's GPU API, and then my abstraction was just not worth it. It just failed, basically. I had to keep adding like absections. Why can't I speak? I had to keep adding exceptions. Jeez, I forgot the word. So this is kind of where I'm at right now, but I want to add, I mean, this is the wrong shader. So I'm trying to get to the other shaders. So this shader has pretty simple, and it's not using any uniform or anything. Victor Blanco's guide gets to that eventually and gives you enough to get started. Victor Blanco. Or Blanco. Oh, is that this one? Right. Okay. Oh, okay, right. Yeah. Yeah, I was reading this actually, but then I got to this point, and I had the same issue that I just talked about earlier, which is like, we're going to use BK Bootstrap. And I was like, oh, well, that's a shame. Yeah, okay. I didn't read who it was by. Maybe I should have. I'm not familiar with this person, so maybe they're famous. It said they're a public figure, so. So hello triangle. Fragment shader is really simple. Vertex shader is also really simple. So I got position and color. Okay, and then if I look at the ones I was using, simple 3D. Position and normal, which is fine. And we've got the push constant, 2 mat 4s. What doesn't it like exactly? He's super active on the graphics programming Discord and incredibly helpful. Okay, that sounds awesome. That's great. I'm looking forward to reading more of his stuff. Pick it up in chapter 3. Okay, I'll have a look at that for sure. What's the problem here? So, I don't know. The shaders are not too different. It's just not liking the uniform. I mean the push constant for some reason. I'm pretty sure I defined it here. Yeah, push constant range is 1. Is that all you have to do, or do you have to do something else? I'm gonna look at the error again. Okay, so we created a pipeline layout that uses descriptor set 0, which is not compatible. So do I still need to make a descriptor set for push constant? Is that what it's complaining about? Oops. So we got these other things we can put in here. So we're gonna write descriptor sets again, I guess. Okay, fine. Set layout count is gonna be 1. What the hell's happening? You guys ever start Do I have some straggler code from my first jab at descriptor sets? I don't think so. Let's see, I was doing it here. So the render code is just a straight line here. Viewport, no. Like if I delete that, oh, you know what? I didn't compile the shaders. And then compile the program. Is that the problem? Well, that is going to be a problem. Yeah, now we get a much more up-to-date error, let's say. Let's see. So this one, okay, push constants was not called yet for the pipeline layout. When we tried to draw, is that when is it? VK command buffer, okay. I mentioned I was building them every time. Oh yeah, sorry, I said I was building them every time, but then it was taking too long to compile, so I commented it out, but maybe I'll just put that back in here. Yeah, so like, see how long that took? Maybe you couldn't tell, but it was like 1.5 seconds or something. Anyway, I'll just leave that in for now. That's fine. So if I uncomment this, we may get success. No, well, this might be successful, but I can't see the triangle because it's like, you heard that as I'll stop eventually. Okay, fair enough. The triangle is a tiny triangle that's like minus 0.5 in world space now. So I'm going to change the vertices, right? So the vertices are here. I'm just going to get rid of this. I'm going to load the model from GLTF. So I've got something called, where is it in? It's in core, GLTF load vertices. There we go. There's a path, assets slash, what is that thing called? Sponsor. Sponsor.bin. Actually, maybe I'll start with a sphere. No, this part should work. I didn't change anything here. It should be fine. So this part should work, and we get back Vertex and index buffer, which I can't call Vertex. No, I can I? Vertex buffer index buffer. Okay, and then actually I'll call it vertices and indices. I think that's in the correct format already. So this needs to be sliced. Jeez, give me that slice. There we go. But we're not drawing indexed, which is going to be a bit of a problem. So we've got to do here command draw instance count first vertex first instance. It's not instanced, it's indexed. Index, yeah, there we go. Cool. Command buffer. Index count is going to be len. And the instance count is 1, I guess. First index is 0, vertex offset is 0, first instance is 0. Okay, I think that should be good. What's the problem here? Okay. Hey Alex, how you doing? I salute you, sir. I'm gonna remove this part actually. This was just testing out that you can actually do cool stuff. It's kind of like immediate mode rendering again. So it's like you're back in Raylib. with all this dynamic rendering stuff. It's pretty cool. So I'm going to, no, I need that. No, I don't need this because I'm gonna get rid of this part. So I've got a barrier, load, begin rendering, draw. I should move this up. Actually, why don't I leave it in and just see what happens? It's gonna be slow as hell, I think. If it even runs. Well, we got a black screen and then we crashed. Good. Update buffer. Data size must be less than or equal to 65,536. Yeah, so probably not doing dynamic updating of a giant mesh. That's fair. I can see that. So let me get rid of this. And this, I think, yeah. Alright, we should be good to go, I think. Oh, interesting. Well, it's not quite correct, but it's definitely a step in the right direction, let's say. Also, my mouse is moving in the opposite direction now. Hang on. Is STL3 and Vulkan reversed in the coordinate system? Or did I multiply my matrices in the wrong order? Is it view times projection or... I can never remember. I'll try this first. There's a sponsor in there if you squint hard enough. Yeah, totally. Okay. No, that was the correct order. Okay, good. Well, what's going on? Let's have a look. Okay, push constants. Yeah. Behold sponsor. Yeah, that's right. Oh, I didn't draw indexed. That is probably the problem. Where is that line? So, oops. Oh, I got an error. You always remember as MVP matrix and then you multiply them backwards, P times V times M. Oh, that's handy. Okay. Apparently this is not... You know what? I didn't actually put in an index buffer. I have to do that, right? Otherwise, how is it going to know what we're drawing? So, vertex buffer. Is it called index buffer? Yeah. Why is there index buffer 2 KHR, index buffer 2, and then index buffer? I don't know. So, hang on a second. So index buffer, okay, and then offset is, I'm just gonna use no offset again. Index type, uint32. Okay, that looks good. Now I need to actually make it. So I didn't make an index buffer, which means I need to do another one of these. I think it's going to be a lot of the same kind of stuff here. And also I don't need transfer destination anymore. That was kind of cool though. And alright, so this is gonna take a hot minute, I think. Actually, you know what? I'm just gonna find and replace all vertices with indices, and then damn it, I missed the first one. Index. Okay, and let's fix what we broke. Index buffer. Is it called index buffer? Yes. Good. Thanks for the follow. Noctian? As in like League of Legends? I don't know if that's right. Okay, so the problem is we don't have these variables, but we're gonna just make them. Hello, how you doing? No, from when you were a kid, you have no idea. Okay, fair enough. Memory requirements, yeah, okay, that's fine. We can just, why don't we scope these? I think we should be okay with that. Maybe? I'm going too far. What am I doing? Alright, index buffer, what's the problem? Yeah, that's supposed to be context. And this is supposed to be not a pointer. Okay, that's fine. Surely that didn't just work, right? Well, it's looking much better. Yeah, whoa. Okay. Interesting. It's upside down. Rave sponsor, yeah. So upside down and inside out, looks like. I'm pretty sure I didn't make a depth buffer yet. So that's going to be a problem. Also, I don't know why my movement is reversed now. I'm just going to change that. Where is it? Somewhere here. Yeah. Okay, there we go. Alright, so the spawns is upside down. Like what? Or am I upside down? Is Vulkan upside down? Like is the world coordinate reversed? Is y up and I mean is up negative y? Can I change that? Surely you can change it, right? You can set the coordinate system or something. Something is inverted from OpenGL. Yeah, let me see. Vulkan set Y orientation. Is that a thing? Y-axis now points down the screen. Why? Vulkan doesn't have any coordinate system. That is all up to my math. Oh, okay. I can fix it with a matrix. Yeah, see, I'm just about to do a refresher course on matrix math. So I haven't quite gotten up to that point. I've done a bunch of linear algebra. I'm just about to do matrices. Because it's been about 20 years since I've used it. Since high school, basically. So... okay. Well, yeah, we can do a rotation. I can't remember which coordinates of the rotation. Alex says, I know because I used to have plus Z as up, but then change it to plus Y to match GLTF defaults. Yeah, that's basically what I've got here. So I've got a GLTF that I'm loading in, and it seems to be that the default, well, the way I've set up my matrices is upside down. So plus Z is up, and I can actually see doing plus Z is up if you go from 2D to 3D. Set the viewport Y to negative window height. Yeah, I guess that would work, right? Viewport height, yeah. So like this. Nope, that did not work. I mean, the model works fine. I'll show you, hang on a second. Here's the SDL3 version. So, the model is okay. And let me just minimize that again because it's really annoying. Check out Vulkan. Alright, so first things first, reversing these coordinates. So what's the best way to do that? Flip y-axis Vulkan, flipping the viewport. Straightforward solution would be to flip the y component. Well, that's what you just said, but didn't actually seem to work as I would have expected. And then this is on the vector. I don't like this kind of stuff. Can you invert y in the projection? Like, this person's having the same problem. Yeah, I probably can do that. Quick and dirty is to reverse it in the shader, I suppose. Height has got to be, oh, you got to set the y to the height. Yeah, I think I'm gonna go with this solution. This is the most familiar to me, because I've done it in other graphics libraries as well. So I'm gonna do that. So do height y equals this. That makes sense, yeah. Doesn't really matter what the coordinate system is as long as it's consistent, and do whatever's intuitive. Okay, now my mouse is upside down again because because I just modified that. Where was it? Here. Pitch. There we go. Alright. Yeah. Okay, this is good. Okay, I like this. That's good. Obviously the colors are all totally wrong because we got no depth buffer and we're using the normals as colors. So I think the next step is to make a depth buffer, hey? Which is going to be somewhere in the pipeline creation up here. No, device, vertex buffer, index buffer, swap chain. Actually, we're going to need a request depth attachments, right? I think. depth stencil attachment, but this is just okay. So we're requesting some amount of images, and the image use is for different things. Sounds like it depends on the math code using C, GLM. Yeah, I'm using GLSL in the Odin core library, which is just, it's just linear algebra. It's like GLM basically. I got lost. So I'm not sure if I need to do something in the swap chain creation here. Maybe add another flag for depth, but then if I ask for that, I think it said I was getting 3 images, which is fine, but then if I wanted to do double buffering, I would have to, I'm not sure exactly. Let's have a look. I'm gonna just search something on Google, I guess. Thank you, Sasha Willems. Vulkan, depth, attachment, depth buffering, vulkantutorial.com. Okay. Right. It's just this page? No, it's very long. Okay. What if you're shit at 3D math but you love graphics programming? Am I cooked? No, I am shit at 3D math and I just started getting into graphics programming. I am studying linear algebra and matrix math again. So I haven't used it in 20 years. So I just started studying it the other day again. I mean, I've used a lot of like random linear algebra, and a lot of stuff is kind of intuitive, like when I was, where is it? I was teaching some collision detection stuff recently, so I had to actually solve things in using math, and you can do a lot of stuff with geometry that just makes sense in your brain. You don't have to know how to multiply matrices, vectors, and quaternions. You just have to know what it means when you do that. Yeah. Okay. This is like super complicated. What is happening here? Find supported depth format? Of course. Okay, I'm gonna go somewhere else. What about this one? Okay, depth image view. Right. You can create a translation, rotation, and scale matrix and then multiply them together into a transform matrix to encapsulate. Yeah. I know about that. I gotta go in like 20 minutes, damn. Okay. So if I look at this guy's example, he's actually just storing what? VMA? See, I'm not using VMA, which is a bit of a problem. So what is it? So it's the same as an allocated buffer, but with VK image instead of VK buffer. All right. So we want to create an image. Very well. Okay. Tiling is very important. GPUs do not store images as 2D arrays of pixels, but instead use complex custom formats. Optimal tells Vulkan to let the driver decide. It won't be possible to read the data from the CPU or to write to it without changing its tiling for us. Okay, that's good to know. VK image create info, what? Oh yeah, image view create. Oh, so this is an image view with the specified format. And I just want to see, where does he put this stuff? In the swap chain, right? Create the image, build an image view, check that it's created. Add to delegation queues. Oh, deletion queues, not delegation. Okay, that's fine. And then yeah, I don't know. I haven't used this guide much. This is actually the legacy guide, it looks like. Let me see the new one. Maybe he talks about depth buffers in here. Okay. Depth testing and stencil configuration. One great downside is that they're hard coded. So if you want to do toggle depth testing, you're going to need 2 pipelines. Isn't that not true anymore? I think maybe he's going to get into that, but let's see. Right. Depth stencil state create info. Okay. I'm not sure. I'm just gonna try wing it. So let's have a look what we got here. Actually, there was one thing I wanted to check from that guide. When he calls, creates the swap chain create info, does he set the stages? Oh, not stages. Image use. Image use. There's no image use. Usage. No image usage. Huh. That's interesting. Do you not have to set this? Oh, maybe it's graphics pipeline, not render pipeline. No? Huh. Maybe it's in this one? Let's see. Setting up the Vulkan commands. No? Okay. Nope. Nope. No. It's never mentioned. I'm a bit confused now. Because you'd think it would be in graphics pipelines, right? Okay. I'm gonna have to read this whole thing at some point. But yeah. Okay, so swap chain create info. Okay, sure. So we create the swap chain. That's right. And we want to use some of them for color and some of them for depth. What if I just run this? I didn't even try that. What happens? We got a bunch of errors. That's good. So, okay, so image tiling optimal doesn't support depth stencil attachment. Okay, that's fine. So when we create an image view from that swap chain, those are not compatible. Okay, that's okay. Are you supposed to make multiple swap chains? One for color buffers and one for depth buffers? Is that a thing? Does anyone know? Meant to? Should you make multiple? You need to create the depth buffer yourself. Swap chain is just for color. Oh, okay. So depth buffer, I can just make a texture. Create. No, they're not called textures, are they? Depth buffers are separate attachments and separate images of their own. Okay, thanks guys. So I want to create an image, I guess, for a depth buffer. I don't know where to put it. I'll just put it up here. Swap chain isn't technically for color, okay. So it's for pushing stuff to the monitor with data of your choice. Right. So swap chain is only for pushing stuff to the monitor. Okay. So create info is going to be image create info. So I need one of those. Swap chain is for presentation. Yeah. Okay. That makes sense. So, do I need any flags? I don't know. I'll do the other things first. Type D2. Yep. Format is going to be. I only need R8, right? So maybe R8 sRGB. Or should I use unorm? Not sure. I'm using sRGB for the other buffer, so maybe I don't even know if that would matter. I need to know more about the formats. Obviously. Extent is going to be with swap chain dimensions dot width. For some reason it's a 3D extent. I guess because you could make a 3D texture, right? You render to your own image buffer that isn't swap chain format, then apply gamma correction, etc. Then copy to the swap chain as the last step. Yeah, that's what I was doing in the version that I showed just before. I actually render to a texture, and then render the debug stuff to a texture, and then combine them and copy them to the swap chain. Swap chain images have a very limited range of supported image formats. Right. This is not enough information, I think. MIP levels 0, I don't need those right now. Array layers, nope. Samples. Yeah. Tiling is what? I guess I'll use optimal. usage is depth stencil attachment, sharing mode exclusive, oh, so I need access to the Q family index count. Where did I use this before? Haven't I done this? Apparently not. Do I need to add a queue here? So I've got a queue, which is named queue, and all it checks for, oh yeah, is if we support graphics. So this is a, what kind of queue is this? In the near future, you'll be switching an image from sRGB to linear color format for things like bloom. Is a linear color format unorm? I don't actually know. Not this queue. Where is it? Here it is. Yeah, one of the unorms. Okay, gotcha. That's interesting. Apparently I just get the device queue based on this index. I need to learn a little bit more about this process. sRGB isn't a linear format, so it does color operations weirdly. Okay. Good to know. Family indices. Do I need this? Is this what I even should be doing? And it's going to go in the image. What's wrong with this? Oh. I guess I'll put it here somewhere. Depth buffer image. Also gonna need an image view, right? Maybe? Okay, I don't know if this is correct. I guess we'll find out. I'll just run the program and we'll see if it gives an error. Okay, need a depth format, but yeah, that's the first step. Okay. Looks like I'm gonna run out of time before that happens, but let's see what this says. The image type is image 2D, the depth must be 1. Oh, okay. That's fair. So let's fix that. Is it here? Depth 1. Alright. What's the next thing? Mipmaps is 0. Mipmaps level must be greater than 0. Okay, fair enough. I will put 1. I would have thought 0 would be default, but I guess not. Okay, what's next? Array layers is 0. Array layers must be greater than 0. Okay, and what's the next one? The following parameters, format type, tiling usage, return format not supported when calling physical device properties 2. The Vulkan spec states Okay, so I can't use R8 sRGB. I will see about U norm, and I will set the array layers to 1. Did we get... No, still not successful. Apparently this format is also not supported. Depth formats start with D. Oh, okay. So you can't just use... Okay, thank you. Oh, gotcha. Alright, what was I using in the other one? It must have been D32S float. Yeah. Okay, thanks for that. Didn't you say you were a newbie? You're a little bit more advanced than a newbie, I think. Awesome. You're just being modest. Alright, that's good. We're not using the depth buffer, but we've apparently made a depth buffer image that hopefully we can write something into at some point. Big D format, yeah. Oh man. One sec. One good thing about having a toddler is having unlimited wipes. So if you spill stuff, you can clean it really easily. Okay. 5 minutes left. I'm gonna stick to the timeline. Yesterday I streamed way too long. I would love to stream all day, but I've got work to do. I mean, this is work, but more work. Okay, so what else? What's a image view create info? Right. Okay, yeah. So I want to create the pipeline, and it's gonna have an attachment, I think. So let's look at this. Blend attachment, depth stencil. So it does have a depth stencil attachment. Depth stencil create info. It's not an attachment, okay. Depth stencil test enable equals true. True. Okay, if I just turn this on and see what the errors say, then maybe that'll be a good... No, there's no errors. Oh, that's unfortunate. Do I use this? Yeah. Okay, I'll just put some more things in here, perhaps. Depth right enable. Hang on, so testing is the reading, I guess? Writing is the stencil test. Front, back, front equals keep. I don't know if this is correct. I'm just putting in random stuff here. 0. 0. I've seen this before. Max depth bounds is just like 1 or something. I don't know. What am I doing? Okay. Too few values in structure literal. Oh, okay. This is a whole thing. Fail operation, pass operation, compare operation. Okay. What the hell should this be? Okay. Pass operation, keep. Fail operation, 0. Depth fail operation. Compare operation, This should be less, right? Less? I don't know. We'll just see what happens, I guess. Compare mask. I don't know if that's correct. Okay, I should look into this instead of just putting random values in here. Reference. I don't know what that means. Okay. Wing it and figure it out in RenderDoc. Yeah, actually, I haven't used RenderDoc yet today. I don't know what the reference is. I don't know what the right mask is. So that's not great. What's the bounds test? We'll just set it to true. Okay, is this gonna fail? No. Definitely not doing anything. It's not turned on, I guess. Or maybe all the settings are totally wrong. I'm gonna copy this and see if anyone has an example. Like this one. Okay, please find this. Okay, so depth test enabled, true. What is this? Okay, so true, true, less or equal for the compare operation. False on the bound, false on the stencil. Okay, let's try that. So less or equal, fair. Depth, bounds, okay, no bounds, apparently. Stencil test, okay. What are these flags though? Like, where is this function? Is it here? No? No. Am I missing something? No. Is it here? No. How do I get to this? Pipeline stencil depth create flags. Pipeline depth stencil create flags. What is that? Is it a function in Vulkan? Okay. Returns an empty struct? What? I need to bind it in the VK rendering info. Oh, okay. Thanks for letting me know. Let's have a look. Rendering. You mean this? Oh yeah, color attachment, depth attachment. Yeah, thank you. This is great. Casey was right. You get a brain upgrade. Stencil attachment format, depth attachment format. Yes, this one. I think. Hang on, this is not the right one, is it? VK.rendering info. This one. All right. Yeah, there we go. Depth attachment, which I guess I need to make. Oh, this is in the rendering. Oh, okay, right. So this is what I'm actually rendering. Gotcha. So we've got a color attachment here. Oh, I see. Got it. Depth attachment. Info. So we're doing... Where is it? Did I not make one? I was just working on it up here somewhere, right? Depth. Oh my god. I'm lost. Create depth buffer, so... Oh no, we just created the depth buffer here. Oh, and then in the pipeline, where is that? It was somewhere down here. Maybe I'm going crazy. Depth stencil. Create info. Right, so we didn't actually create an attachment. Okay, gotcha. So I need to make one here. I guess rendering attachment info. Is it? Oh, I didn't check the type. Of course, that doesn't work anymore. Yeah. I'm just going to copy this. What am I doing? Okay, so we did an image view. So that would be depth, image, depth buffer, image view. This is depth, stencil, attachment, optional, clear, store, and a clear value. No, we don't need a clear value, right? That's just for clearing. Color. Do we need? Yeah, we need to clear it. We need to store it. Okay. So this we didn't make yet, right? We didn't make that yet. Okay. So depth buffer image we did make here. So we're gonna have to make create image view, which I'll find somewhere else in my code and copy this. Okay, and then I will just change this to depth buffer image view. This is not color. This is depth, and this is going to be not that format, right? D32 as float, and this is not the right image. Okay, did that work? Let's see. Well, we have a black screen. Need the view and to allocate and bind image memory. Oh, right. Yeah, I did make memory, didn't I? Allocate. Here it is. No, not this one. Is it this one? No, no. Oh, I need to allocate memory for it. Allocate and bind to image memory. Okay, let's see. I'm really busting to go to the toilet and I'm 5 minutes overdue. But I feel like we're so close. Alright, so create an image view. So the swap chain must allocate its own image memory, right? So we need to do that ourselves. Need the view and to allocate the bind image memory. Allocate and bind image memory. Okay. What do we got? Allocate memory. Okay, so I need some memory allocate info. I'm gonna call it that because I can't think of a name right now. So it's gonna be, okay. Memory allocate info, allocation size. So this would be, I guess, size of F32 times swap chain dimensions dot width times. I don't know if this is the correct way to do this, but that's what it should be, right? Memory type index. What is that? Find memory type. Oh, okay, I have a function for it. Is that going to help? Host visible, host coherent. That sounds good. Memory requirements. Are you kidding me? I need memory requirements for an image. Get memory requirements. Is that what it was called? Get image memory requirements. There we go. device. Okay, the image is here. What's it called? Dot depth buffer image, and the memory requirements are gonna go in there. All right, finally, hopefully, device. The allocate info is here, and the allocator callback is nothing, and the memory. Hang on a second. Device memory. Is that a raw pointer? Wait, I've used this elsewhere. Oh, okay, so I need like a vertex buffer, depth buffer memory, I guess. But now, how do I associate the memory of the depth buffer with the buffer itself? I'm using with no memory bound. Memory should be bound by calling bind memory, create image view. Okay, well, all right, that's good. That answers that question, I think. So, create image view. So now I got to bind the memory here. Where is it? Allocate memory. Bind memory, bind image memory, was it? Is that what it said? Damn it. Yes. Allocation size needs to be memory requirements.size. Ah. Gotcha. Okay, that makes sense. Because there's probably some metadata in there or something, right? Thank you for that. pk underscore context dot device. The image is the image. The device memory is the memory that we just got back. So I probably don't need to store this, but I mean on this struct. That's alright. The offset is going to be 0. And make sure you are setting the image extent when you create the image. Okay, thank you. I am setting it. Yep. Ah, damn. Failed to find suitable memory type. Well, that's not great. Damn it. Find memory type for... What's wrong with this? Is that right? Host visible, host coherent. I don't even know if this is the right memory type. What other options are there? Device local, host visible, protected, yeah. Use device local. Okay. I'm gonna have to look at what these actually mean. Oh, this is the vertex buffer. Oops. Don't need to write it from the CPU. That's correct, yeah. So the host is the CPU. Okay, gotcha. Device local means only on the GPU. Wow. Close. What's the problem now? Validation error. Unused attachment. So when we draw indexed, so the depth attachment format must match corresponding format in the pipeline, which is undefined. Depth attachment format in the pipeline. So we need to go to the pipeline create info. Depth. Is that? It's up here, isn't it? Oof. I can't hold it any longer. I'll be right back. All right. Okay, we're so close. I can smell it. So the message was, the image view was not null handle. The value of pipeline rendering create info depth attachment format used to create the currently bound graphics pipeline must be equal to the other one. So we used float32, and on the pipeline rendering create info, it's undefined. Which is interesting because I thought pipeline, no, this is graphics pipeline. Pipeline rendering create info, it's here. Okay, depth attachment format is going to be D32 S float. Alright, that's good. Okay. Alright, well, we got no errors, but we also don't have depth testing, or wait, well, no, we do. We do. It's just inverted. Nice. Awesome. Wow, thanks so much for your help. I gotta have a look at this though. I don't know what this should all be. Is this wrong? Maybe. Compare op, if I change this to greater than or equal, or if I change this compare mask, if I just delete it, I don't know. Maybe it's something else as well. I got no idea what the... It could be... what if I set this to counterclockwise? Just as a test. Is that better? No, actually we don't have depth testing. Well, not when it's counterclockwise. Okay, interesting. So clockwise we do, it looks like. Let me just test that again down here. No, we don't. Unless it's inverted. Like that wall over there is disappearing, right? But it could just be I'm going out of range. No. Not sure. Anyway, definitely. Yeah. See, that looks like it's got depth testing, right? We should be able to see both of those things. It's just that the rest of the rendering is all messed up. So I think the depth testing is working somewhat. Let's see. What if we change the fragment shader here to be more advanced? Somewhat more advanced. Maybe actually we just use a set color for this, or we use some really simple sunlight calculation. I don't think that's using anything. We need this sunlight color and I guess the model color. Oh, did I cut it? I cut it. Okay, I'll grab this. This should make it a little bit easier to, you know, visualize. So I'll grab this. I'll copy that, I guess. And we'll grab this. So no light color. No light, just sunlight. Alright, that's a little bit less, you know, crazy. Now I can see the depth testing is not working as expected. But there's no error. So I think it's just the settings are wrong. If we look at, actually, let's see, CMD depth. Set depth test enable. I mean, maybe it's not enabled because we're using this dynamic rendering thing. I don't know. Okay, seems to be the same, but that's fine. We'll leave that there. Yeah, so I think it's going to be in this setting here. That's kind of why I wanted to look at someone else's code for this. If I just search for this on GitHub, actually, VK pipeline, not in this repository, in another repository. Code, so many results, and I just want kind of a normal version, so I'm going to go to C as the language. And we'll just see if someone's got something like, here we go, mini Vulkan. No, not mini Vulkan. We want it to be a C file. Maybe this one. Demos. Cube. So they've got this DS variable here. And let's have a look what they set it to. All right. So, depth test enable true, write enable true. Compare operation is less or equal. That's what we've got. Depth bounds false. That's what we've got. Fail op is stencil or keep. Pass op is stencil or keep. Okay, that's different. We don't have a... Is that... Hello? Okay, there is no... Oh, that's the back. Back. Front is the same as the back. Okay. There is no stencil or keep. I guess it's just keep then. Fail op is also keep. Okay. Depth fail op. They don't even set that. Okay. Compare op. Compare mask. They don't set that either. So I'll set the back to the same. It seems weird to me, but anyway. Okay. Min depth bounds and max depth bounds are not set. Okay. Now we have errors. Right. Doesn't set up dynamic state depth test enable, but since the command pipeline, the related dynamic state commands depth test enable has been called. If the pipeline is bound to the pipeline bind point, there must not have been any calls to dynamic state setting commands for any state not specified as dynamic in the pipeline object. Okay, so I need to go and set up the dynamic commands. Where is that again? Okay, yeah, I think I understand the problem. I mean, I understand the error somewhat. So, dynamic state, dynamic create info, here it is. Dynamic states is, where is that? Here. So I can add, no. I can't add anything apparently. Depth bias, no. Depth test enable, yeah. Okay, still no depth testing. Well, at least I don't think so. Definitely doesn't look like it. It is enabled though, so I'm not sure. Alright, well, I'm gonna have to leave it there, I think. I don't think I can keep going. Wait, depth compare operation always. Is that what they had? No, less or equal. Alright, let's try that. That makes sense. I don't know why it was set to always. Oh, okay, now I can't see anything. That's cool. Oh, and that was this compare operation. Wait, what? Alright. Compare op is compare op always. Oh, they had it reversed. So this is less than or equal to, and this is always. Okay, now I just can't see anything. So everything's getting cut out, I guess. Front and back is just for stencil, you think? Okay. Well, we're not using that, right? So we can probably just unset it. Wrong thing. Oh, that's why it says stencil op keep. So it's just keep. Gotcha. Less or equal, true, true. Yeah, alright. Well, that's that part. But let's have a look for the word depth. I'm just going to have a look through here. They've got the... Oh, they've got a struct for it. Device memory, image view, allocate info, and image. Am I clearing the depth buffer with 0? It should... Should it not do that when I load it? It should clear, right? That's what this means. Oh no, do I have to actually clear the memory itself? Let's see. I'll see if this guy does it. Oh, you mean this? Clear values, depth stencil 1, 0? Is that a thing? Okay. Damn. Depth stencil clear value. Depth 0. Oh, so the depth would be 1, stencil 0, is that right? Okay, so I do need a clear value in here. It's not going to work apparently. I need to set it to, what was it called? Depth stencil. Nice, good catch. Hey. Very nice. Looks a little bit weird, I think. That's okay, nothing we can't play around with. But yeah, that's great. Thank you for your assistance. You've been really helpful. What was that? I think I saw something weird. Yeah. No, no, it looks fine. All right, cool. I love directional lighting, by the way. It's so simple and so, it just adds a lot for what it costs, which is like a few lines of code, which is just this right here. Yeah. Anyway, that's it. Thanks to you, FLGA. This has been a stream success. Well, we didn't quite get to composing the two things, but we're very close, so I'm still going to call it a success. And yeah, I got to go because I'm 30 minutes overdue. And there is a lot of work to do. So thank you very much, and I will see you tomorrow. I'll probably be streaming tomorrow around starting 30 minutes from now, because basically my schedule is a bit different. But yeah, I think Tuesdays and Thursdays I'll do the early stream, and Tuesdays and Thursdays and Sundays. But yeah. Anyway, thank you and take care.